Mm, linear regression. So let's do the classification. So, where is it? Okay, so I think it there. So this go back. So this drive is going out. So why they keep telling me you can do so? Oh, okay. So they used an LTK here. Okay, that's good. I know some bit already. Okay, so since I know about NLTK already, I'll take a look at the quiz so we can go ahead and do the quiz together.
Yeah, sure.
Okay, let's. The most useful 11 word in the selected words. So let's see the most useful 11 word. This is so recommend this. Plot the product reports reviews. Okay. Examine the products sold, the reviews of most popular shopping. Okay. Let me plug in my internet line. I think my internet is a bit slow today. So what the length of the reviews is that mean like they have 785, right?
Yes. Didn't import the function. The
Oh,
cell while you are importing it, you didn't run it.
let
Just
me,
there. Just there. Below. It is below.
okay. So let's see what is this counter. What does counter mean? It is an
Counter. Try to add another argument between the bracket after values.
Here, can you show me? I'm not quite understanding.
Write comma and press space key.
Yes, you can control it.
Okay. Okay, counter. This subclass for counting hashable items, sometimes called. No, don't write anything. I'm reading
Okay.
doc 3. This subclass for counting hashable items, sometimes called a bag or multiset. Elements are stored as dictionary keys and their counts are stored as dictionary values. Okay. So I think in this case, it takes the rating, the column of ratings having different values. It takes the unit values and compute the number of times these unique values appear and store as dictionary. The white counter does.
And
You
this
got it?
class for no, not quite. Let me read it for a little bit. So
Okay.
this class for counting hashable items, sometimes called a bag or multiset. Oh, okay. So okay, I got it. Okay,
Right.
I see most common. Oh, okay. Okay. Give me a minute. I forgot my phone. I'll be right back.
Okay, sure.
Okay, I'm back. So,
Okay.
ouch, ouch. Okay. um. So let's see. Counter pause. Count. Mm, So they were, so in the first one, rating counter is that they are having a dictionary here. Let me try to print it out to see what it means.
The dictionary doesn't have this method.
Oh, that's right.
The
So,
method are items, case, or values for a dictionary.
oh, okay, that's right. So in that case, how do I get the?
Add that items to see. Dot items, yeah. Now I have to add the bracket.
Oh, okay. Okay, I understand now. Mm, so I have a list of dictionary items.
Now you have a dictionary.
Pardon?
You have a dictionary.
Yes. So is it the rating? So they use a key set, right, to hash them together. Okay. So I want to find out what does this do. So this is also a dictionary, right?
I don't know.
Oh, okay. So numpy dot array. So it's an array. Mm, oh, it's just the length. It's just the length of
Yeah.
counter. Okay. So
It is an array of integers ranging from 1 to the length
yeah. Okay. I see. Rating counter. So.
1, 2, 3, 4, 5.
I see. Oh, okay.
No, 0, 1, 2, 3, 4. I think so.
Oh, okay. I see now. Okay. So, oh, they use zip method. So they match between the label and the cow, right? I remember this is what zip do.
Zip. In this case, the zip with this method, with this argument,
Okay,
is
here's
forgetting in one array the case, in the count, it will store the values. This is what that line does.
I'm not sure. Let me see. Let me read more. Zip iter. So, oh, so it iterate those. Mm. Okay, so this is the dictionary and can you explain more for me? Like, what would zip do? Like, could you draw out? Like, what would zip do?
Mm,
Like,
uh,
they match. I know, like, they're supposed to iterate, but I'm not sure, like, what they iterate with. Like, this pair with this pair.
yeah, it iterates on each pair. First, it takes the first pair. The first value in the pair, you store it in the counter labels. The second value of the pair, the count. It is like writing for, I don't know, it's like writing a for loop
Oh, okay.
and then appending each value to the list.
Oh, okay. So it's a recursive, but then I don't understand the syntax. You know, like, what does what does the star here do?
The star, it is for, how to say, the
Multiply.
star, no, not multiply. It's for iterating for each element in the dictionary.
Oh, okay. Okay, so okay. Let me take a look more on the zip. I'm still not quite get. Zip I think I read somewhere in this. Okay, yes, I understand. But then, so in here, like it iterate between number and letter, right? But in here, they just have like this star. That's what bugging me. Like when they have this star, what does it supposed to do?
Uh, the zip takes list of elements. So when you put the star, you got list of key value from the dictionary.
Oh, that's a good idea. Let me remove the star to see what it.
It won't work like it should.
So, for example, if the case here, okay, if I don't have the star, then it would be like this. And it might will be because, oh, okay, I see now. Ah, okay, I got it.
Okay, great.
Okay, let me just make sure that I will remember this. Okay, so this is the book item. Great. Basically, is we put all of this column in one and all. Oh, okay. Okay, I got it. Awesome. PL bar count post count. Okay, I got this one. So basically, it just make it to be a dictionary. Okay, I got this now. Build a sentiment classifier. So rating counter is count product rating. Okay, I understand this. Creating training. Okay, I understand this part already. Gosh, this take forever.
You've got a lot of data. This is why it's slow.
Look at others. Okay. Oh, okay. This is okay. I think I need to go back to see what is the. Oh, I think I already did actually. Let me see this. Okay, so case study, so it doesn't have. Actually, while we are waiting for, oh, it's only trend. Let's see.
Yeah, it's finished.
Oh, okay, that's not bad. Aware. Okay, so oh, just a question. I have a question. So, how do you find out the max ether for this?
I think that he just give a value. But if you want to find the right value, you have to make a grid search or a randomized search to see what is the best one to choose.
Oh, okay.
Or not having over 15 or under 15.
So you have to try out like random number to see which one is working, right?
Random number. No, it returns a set of, yes, random number, or you give a set of values.
Oh, okay, I see.
A list of possible set of values you think will be good
I
for
see.
conversion or convergence.
Okay, I see now. So while we are waiting for the logistic regression, so could we look at the clustering problem together?
Sure.
So lesson objective is quiz. Okay, let's watch some videos together while waiting for it to run. Oh, I think it's finished. Oh,
Yeah, the number of iterations not enough for reaching the convergence.
oh,
The model is not converging.
so I just increase it, right?
Yeah.
Okay. Let's try again.
I don't.
Oh, you couldn't hear you couldn't hear, right?
No.
Sorry, share computer side.
Words correctly. Carlos can correct me later.
Okay.
But the point is that he likes this article. And what we'd like to do is retrieve another article that he might be interested in reading. But the question is, how do we do this? There are lots and lots of articles out there, and I can't expect him to go and read each of them and say, yes, he's interested, or no, he's not. So we'd like to think of a way to automatically retrieve a document that might be of interest to him. But questions here are, first, how do we measure similarities between articles? We need to have that in order to say that this article is similar to the one that he's reading now and might also be of interest to him, or that here's a large set of articles that are very different and probably are not of interest to him. And then the second question is, how are we going to search over the articles that exist out there and retrieve the next article to recommend?
Take a while.
So the first thing we need to describe is, how are we going to represent the documents that we're looking at? Okay, so perhaps the most popular model to represent a document is something called the bag of words model, where we simply ignore the order of words that are present in the document. And the reason it's called a bag of words model is we think of taking a bag, throwing all the words from that document into the bag, shaking it up, and the new document we've created with the words all jumbled up has exactly the same representation, as I'll describe, as the original document where the words were ordered. And what we're going to do, instead of considering the structure, the order of the words, is we're simply going to count the number of instances of every word in the document. So let's look at a specific example of this. And so in this document, we're going to imagine that there's just one sentence, and that sentence says that Carlos calls the sport football, Emily calls the sport soccer. Actually, I guess that's really two sentences, but that's the entire document. And what we're going to do to count the number of instances of words in this very short document is we're just going to look at a vector, and this vector is defined over the vocabulary in whatever language we're looking at. So maybe one word in our vocabulary is the name Carlos. Another place in this vector is the index for the.
Okay, we increase it and we count it. So evaluate. Okay, we have our test features. So test features too, it doesn't mean like it get the second, it get from the second column, right?
No, I don't think so. Text feature 2 is taking the two first lines.
Oh, okay. The first one. Oh, that's right. I need to get, I need to see this. This is the parameter of AUC, right? Under curve. What is it?
Yeah.
Area under curve. So these are the value of the area under curve.
False positive rate, true positive rate, threshold.
Okay, so basically these are the parameters for classification evaluation. So these, oh, okay. So ROC and AUC is just like summarize up of the evaluation of the classification, right?
Yeah, this is a summary graph. It shows how well the model performs.
Oh, okay. So what does, if the data is fall under the area of curve mean?
Yes, it means it is performing well. The more the upper left point is far from the red line, the better the model performs.
Oh, okay. So if it in this, if it in this area, then it's good. It's good, right?
Yes, it's good.
Okay, let me just make sure to. So if it in this area, then the model is good.
The greater this area is, the better the model performance.
Pardon?
Give me a minute, I'll be right back.
Okay, okay.
Yeah, I'm here.
Oh, okay. So my question is, so I understand this is AUC, right? Area under curve. So if is the if our model is in this side, that is good, right?
I don't, it's not that. This area is not the model. Sorry, I've got to call again. Give me a minute. Ouais. Je suis à la maison. La maman m'a dit qu'il y a une dame qui va venir. Ce soir, un peu occupée. Il communique avec le clan, Nicolas et Marie. Donc, je risque de les gêner un peu. La dame communique avec Nicolas et Marie online. Je risque de les gêner un peu. Quoi. Ah, donc, peut-être qu'elle ne va pas venir alors. C'est possible qu'elle vienne. Bon, moi, je passe peut-être le soir. Mais là, on va se checker.
So my question is that like when the values in this side, I mean like when our model is in this side, and it is good, right?
I don't think that we can say the model is in this side. What we could say is that the area under the curve, it is all the space you just jot on. And more this area is big, the better is the model performing.
I see. So let me take a look at classification. Okay, maybe I'm missing something else.
Okay.
Quickly take a look at. Okay.
In the regression model, we talked about a little bit about doing this classification. So we're giving a set of test examples of the form sushi was great is a positive sentence, and we're trying to figure out how many of these test sentences we get correct and how many do we make mistakes at. So what we're going to do is take the sentence sushi is great and feed it through the classifier, through the learn classifier. But we don't want the learn classifier to actually see the true label. We want to see if it gets the true label right. So we're going to hide that true label. So the sentence gets fed to the learn classifier while the true label is hidden. And now given the sentence, we're going to predict y hat as being positive. So we believe this is a positive sentence, and so we've made a correct prediction. So the number of correct sentences goes up by 1. Now let's take another sentence, another test example. So let's say you say, the food was okay as a negative sentence. So that's a bit of an ambiguous sentence, but it's been labeled as negative in the training set. So now I feed the sentence to the classifier, I hide the label, and let's see what the classifier does. In this case, because the food was okay, it can be billed as positive, maybe it makes a prediction that this is a positive sentence. I've made a mistake because the true label is negative. So we say, hey, mistake was made. We now have one more mistake. So we have one correct classification and one mistake. Now we do this for every sentence in the corpus. There are two common measures of quality in classification. So for example, one of them is the notion of error. So error measures the fraction of the test examples that we make mistakes on. So what we just do is say, out of all of the sentences that are classified, how many mistakes they made, so number of mistakes, and I divide that by the total number of test sentences. So for example, if there were 100 test sentences and I made 10 mistakes, then our error will be 0.1 or 10%. Now, the best possible error that I can make is 0, basically. I make no mistakes. Now, it's common to, instead of talk about error, to also talk about accuracy of your classifier. So accuracy is exactly the opposite of that. So in accuracy, some make number
So
that
I'm trying to look for area under, what is it? Area under curve. So I'm not sure. So it should be learning curve, right? Let's try.
we need to learn. And this is a really difficult and complex question in machine learning. So, of course, the more data you have, the better, as long as the quality of the data is good. Having bad data, lots of bad data, is much worse than having much less, much fewer data points, but really good, clean, high-quality data points. Now, there's some theoretical techniques to analyze how much data you need. Many of those help you understand kind of the overall trends, but really tend to be too loose to use in practice. In practice, there's some empirical techniques to really try to understand how much error we're making and what that kind of error looks like. And in the follow-up courses, we're going to explore those techniques much further, but let me give you a little bit of guidance and a little insight on what I can do within the classification setting. Now, an important representation for this relationship between data and quality is what's called a learning curve. So a learning curve relates the amount of data that we have for training with the error that we're making. And here we're talking about test error. Now, if you have very little data for training, then your test error is going to be high. But if you have a lot of data for training, your test error is going to be low. And now,
Let me explain you the rock cut. We could go back in the Jupyter notebook. Yeah, it is plotting on the x-axis. It is the false positive rate, and the y-axis is the true positive rate. The best model should have the false positive rate equals 0. It means that whatever the threshold we chose, it have to be the curve completely sticking on the y-axis. It means that the false positive rate is always equal 0. And the true
So-
positive rate, we have to predict all the positive correctly. So the curve should be sticking the x-axis at the top completely. It means that whatever the threshold we chose, the true positive rate is always 100%. But you see, there is a
I cannot hear you clear. So what you meant is that so the false positive rate is always equal to 0, right?
in the best case, it should be always equal to 0.
Mm-hmm.
And the true positive rate in the best case should be always equal to 1. So the curve should be a line running from 0 to, no, the curve should be like this, running from 0 to the left top corner, and from the left top corner to the right top corner.
So you say in the optimized case, the false positive rate is always equal to 0, and the true positive rate is always equal to 1, right? And
Yes, whatever the threshold to pick.
so how do we know that in this model? What
Yeah.
is this model is telling us?
Yeah, you see, when we take the curve, it starts from 0, and then there are values for which the false positive rate start to increase. It is not anymore 0%. The
Pardon?
same thing. You see the area above the curve.
Yes.
The best case, it shouldn't have any area above the curve.
Area above the curve is this area, right?
Should be equal 0. The
This
best case.
one.
Yes.
Oh, okay. If it equal to 0, then
Yeah.
oh, okay.
And the true positive will be equals 1. But it's not.
Oh. Okay,
always
so
the
the
case.
best case would be let me draw. Okay. So the best case that it would be here, right?
Yeah.
Oh, sorry. So the best case that it would be, oh, okay, I see. I got.
Yeah. Great.
So, okay, let's see. So review based on. Okay, I think we can start with the quiz 1. Okay, I already did this. So I need to do the case study. In the reviews in dataset. So I need to find the most word that happen. So where?
Are you sure that is what they asked?
Oh, here, sorry. So they ask in the review dataset which word is most used out of 11 words in the selected words. So let's find this. Selected word. Here, let me share with you the notebook. Can you see the notebook?
Not yet in the message.
I sent it in chat. So I'm
In chat, okay.
yes. So I'm a little bit confused. Like I don't understand what is the selected word. Supposed to be a function.
I need to be authorized first.
Oh, sorry. Let me share with you with another. Okay, you should be able to do it now. So
Great. No. Okay, what the selected is the giraffe reviews.
yeah, so yeah, that's why I was confused because I couldn't find the selected word. You know, which was in the selected words. So in the review in the data set. So I think we need to make a backup word out of this one. See if we have the answer somewhere. Let's see what an answer for this. I want to know like how they select data set. Okay. I'll just ask the group on this. I have no idea. So, so let me ask the group on this. Let's keep this. Selected course model. Test data. Which following range contain the accuracy of sentiment model?
That is in your note from the course.
Pardon?
I think that the answer should be in the course if there were a notebook And if you run a model there
It's not in the notebook.
of the sentiment model from lecture, okay, it is in this notebook.
I thought it's in the notebook.
Yes, it was 0.93.
Oh, okay. It's from the lecture. Ah, I'm so silly.
No, it is from this one. Try to see. It is 0.93. The sentiment model you just run.
Pardon, can you say it again? I cannot hear you.
The sentiment model you just run. The accuracy was 0.93, if you remember.
Oh, you meant like it's in here, right? 0.
Just above this curve. Yeah, just there.
Oh, okay.
Model score.
0.93. So this one.
Yeah.
Ah, okay. So the model score. Okay. On the test data, which the following range contain. So we need to print out. I don't know. I forgot. Let's use this. Okay.
Did you compute it on the test data?
Yes, I'm computing on the test data. So we are trying to find which of the following range contain the accuracy.
Where did you compute the accuracy of the test data?
Oh, so we need to compute the accuracy. Oh, okay. So accuracy. So let me just write it here first. So accuracy. So I remember is true positive plus. Oh wait, we have the formula for it, right? So I don't need to write it. So let me see accuracy syntax. So we need to know how to calculate if right and is true.
Try to look for Python model classification summary.
Okay, I'll show you how to get unlimited access without have to pay. See, now you can read everything.
Okay, nice.
Yeah. It's record, so it doesn't work. Jeez. There's no example code. How come it's so much more difficult to find example code in Python and PySpark? Please have some.
Go back in the Jupyter notebook.
Okay.
Try to import from sklearn.metric, import classification report.
Okay. Can you send me the syntax?
Okay, check in the chat.
Yes. I mean the libraries.
I sent it to you.
Oh. Let's see. Awesome. So let me open this.
This is the line just below you have to use.
So I need to define my eTrue and ePred, right?
You already have defined it.
I did?
Yeah. It is already defined.
Oh,
Y true, it is the Y3. And your second one, this is the one you predict.
so okay. So my eTrue and ePred is already defined. So if I just do like this, would it show anything? No.
You don't have the same case than the example. Don't need to define the target name. Remove the target names.
Oh, okay.
Yeah. You forgot the P at the beginning. P, print.
So I don't need this.
No, let it. Remove target names.
Oh, okay.
Okay, missing the print. Wait. Now, adapter in your case, how did you call your Y2?
Pardon?
Call up to see how you call your Y2.
That's what I'm confused because I don't remember I defined eTrue.
Yeah, you define it where you split the data.
Oh, yes. I remember now. Yes. Hang on, I need to go back to eTrue. I saw that in the script in my company too, but I didn't know what this is. eTrue. Yeah, actually, I didn't know what this is. Let me take a look at it. Oh, so it's basically it's a false positive and true positive. Oh, okay. So it's basically just the combination of true positive, false positive. Okay, I see. So even here, yes.
Go back in the classification report.
Here, right? Classification report. Oh.
Okay, replace Y2 by test labels. Test labels.
Oh, test.
And replace Y by test predictions. Okay, test prediction is sentiment model dot predict. So remove the test prediction. Remove the test prediction. Right, sentiment model. dot predict test features. No, open the brackets and write test features. Okay.
How did you do that? I still don't understand.
You need the Y2, the real labels. It is in the test labels, 0, 1, or 1, 0. And you need the value predicted based on the features. And to get this one, the prediction values, you have to use the predict method of the model you train. And you apply it on the test features. What the method predict does, it takes the weight from the sentiment model and make a column-wise multiplication with the test features, and it returns the predicted value for each review.
Oh, okay.
Here you got Y2, Y prep, and you can make the report. So here you have the accuracy. It is 0.94. Try to see which threshold matches it in your quiz.
I see. I see. Okay. So here. So in here, right?
Are you sure?
Oh wait.
Accuracy.
Accuracy. Accuracy is 0.94.
Yeah.
So okay. Let's see. Oh, it's time for me to go. Can we continue this on tomorrow?
Sure, we can.
Oh, can we study a little bit earlier tomorrow because I have something to do at 8. So can we go around like 6 o'clock?
Okay.
Okay.
Good for me.
At 6. Yeah. All right. Bye-bye.
Yeah. Bye-bye. Thanks. Have a nice day.
Have a nice day. Au revoir.
Au revoir. D'accord.